Hi everyone, this video is part of the RoadTest program powered by Element14. Along with my OpenScope MZ, I run an analysis of an RC circuit. Let's go. Well, all the environment is set for me to work with my OpenScope. This can be easily achieved following the tutorials at the products page. Now, let's put our hands on. For this, I'll use a simple RC circuit with a 10 mic capacitor and a 10 key resistor. Connecting like the diagram, the circuit is set. Let's check the step response of the circuit. In the Digilent instrument panel, click direction so it's highlighted. Set pin 1 as an output. To physically connect your OpenScope, click pin. Then a map showed so you can physically connect your board in your OpenScope together. Then click direction so it's created. Now set the trigger to channel 1 at 2085 millivolts. It's not a magic number, just wait. Set trigger to rising edge, hit single. Toggle digital out to low, then toggle high. And there is our step signal in blue and our step response of an RC circuit in orange, like in the books, but now it's for real. And that trigger at 2085 millivolts. Remember that for an RC circuit, the time constant is the time for a capacitor to reach about 63.2% of the source voltage. From the books, time constant or tau is given by resistance multiplied by capacitance. In this case, it's 100 milliseconds. So, 2085 millivolts is 63.2% of 3.3 volts, which is our GPIO logical level here. And 100 milliseconds is the time for the capacitor to reach that percentage. Now, click cursors. Select type as time and left others as they are. From 0 to the trigger level, the time elapsed is 100 milliseconds. Isn't it nice? The graph shows that theory is not only true, but real. Now, let's see RC circuit as a filter.